We want to find the first several terms of the Taylor series for f of x equals x cubed, centered at x equals -3, and then give the first few coefficients, c sub 0 through c sub 4. The Taylor series for any function is equal to the infinite series where we have the summation from n equals 0 to infinity of the nth derivative of f evaluated at c, where the series is centered at c, divided by n factorial times the quantity x minus c raised to the power of n. If we look at the expansion of the power series here on the right, notice how the first two terms don't have a denominator because when n is 0, we have 0 factorial, which is equal to 1, and when n is 1, we have 1 factorial, which is equal to 1. So the Taylor series for our function f of x would be the summation from n equals 0 to infinity of the nth derivative of f evaluated at -3 divided by n factorial times the quantity x minus -3 or x plus 3 raised to the nth. So when n is 0, we just have f of -3. When n is 1, we have f prime of -3 times the quantity x plus 3 raised to the first. And then when n is 2, we have f double prime of -3 divided by 2 factorial times the quantity x plus 3 raised to the second, plus when n is 3, we have f triple prime of -3 divided by 3 factorial times the quantity x plus 3 to the third. We need to find at least one more term to find the first 5 coefficients. So we'll have plus the fourth derivative of f evaluated at -3 divided by 4 factorial times the quantity x plus 3 to the fourth, and so on. Now for the next step, we'll find all of these function values, f of -3, f prime of -3, f double prime of -3, f triple prime of -3, and finally the fourth derivative of f evaluated at -3. So starting with f of x equals x cubed, well, f prime of x would be equal to 3x squared. F double prime of x would be equal to 6x. F triple prime of x would be equal to 6. And the fourth derivative of f would be equal to 0. So f of -3 would be equal to -27. F prime of -3 would be equal to +27. F double prime of -3 would be equal to -18. F triple prime of -3 is 6. And the fourth derivative of -3 is equal to 0. And now we'll perform substitution. So our series is equal to, we have f of -3, that's -27. And then f prime of -3 is equal to 27, so we'd have plus 27 times the quantity x plus 3, plus, here we have f double prime of -3 divided by 2 factorial. 2 factorial is equal to 2, so we'd have -18 divided by 2, which is -9. So let's write this as minus 9 times the quantity x plus 3 squared. Next we have plus f triple prime of -3 is equal to 6. 3 factorial is also equal to 6, so we just have 1 times the quantity x plus 3 to the third. And the fourth derivative of f evaluated at -3 is actually 0. So here we just have plus 0 times the quantity x plus 3 to the fourth, and so on. Of course, this product here is 0. Let's leave it in this form so we can find c sub 0 through c sub 4. C sub 0 is -27. C sub 1 is +27. C sub 2 is -9. C sub 3 is +1. And C sub 4 is 0. So again, we have -27, +27, -9, 1, and 0. So because the original function is just a basic polynomial function, when using a Taylor series to approximate this function, notice how the fourth derivative and higher would always be 0, and therefore in this case the Taylor series is not an infinite series. It actually ends after this product here, so we can go ahead and just erase this part of the series. And because each term in the remaining series would be 0, these terms of the Taylor series are exactly equal to the original function f of x. So if we multiplied this out and simplified it, it would simplify perfectly to just x cubed. Of course, this is a special case because the original function f of x is a basic polynomial function. To verify this, let's go ahead and graph these terms of the Taylor series, which would be called a Taylor polynomial, and compare it to the original function. The original function is graphed here in blue, and our Taylor polynomial is graphed here in red. As you can see graphically, they're exactly the same. I hope you found this helpful.